If light is the fastest thing, why can a black hole still suck it in? Light, the fastest thing in the universe, it races through space at nearly 300,000 kilometers per second. Nothing we know can outrun it. Not rockets, not particles, not even time itself can slow it down. So here's the question that bends both minds and physics. If light is so fast, why can't it escape a black hole? To answer that, we need to dive into the heart of one of the strangest and most powerful objects ever discovered, the black hole. And the key isn't speed, it's gravity. But not gravity the way we learned about it in school. What a black hole does to space and time is so extreme that even light, the cosmic speed limit itself, has no way out. Let's start from the beginning. A black hole isn't a hole in the traditional sense. It's what's left behind when a massive star dies. When a star many times heavier than our sun runs out of fuel, it collapses under its own gravity. The core compresses tighter and tighter until the atoms themselves can't resist. The protons, neutrons, and electrons get crushed together into an incredibly dense point, called a singularity. Around that point, gravity becomes so strong that it warps the fabric of space-time. Einstein's theory of general relativity explains this perfectly. Gravity isn't just a force pulling things down, it's the bending of space and time caused by mass. Imagine placing a heavy bowling ball on a stretched rubber sheet. The ball sinks down, and any smaller object you roll nearby will spiral toward it. That's how planets orbit stars. Now imagine that bowling ball becoming infinitely heavy. The sheet would curve so much that it tears open. That's a black hole. It doesn't just curve space-time, it folds it to the point where all paths lead inward, even the path light travels. This boundary, the point of no return, is called the event horizon. Once light crosses that line, it's gone, forever. Not because the black hole sucks it like a vacuum cleaner, but because the geometry of space-time itself changes direction. Inside the event horizon, all directions, including the one we call outward, point toward the singularity. It's like being stuck in a waterfall. No matter how fast you swim upward, the water flow is so strong that you're dragged down anyway. Light doesn't slow down. It's still moving at full speed, but every possible path it could take bends back toward the black hole. Outside the event horizon, however, light can still fight back. You might have seen pictures of a glowing ring around a black circle. That's the accretion disk, made of gas and dust being pulled in. As this material spirals closer, it heats up to millions of degrees, emitting intense light and radiation. Some of that light barely escapes, traveling around the black hole multiple times before shooting out into the universe. That's why we can see the edge of a black hole even though the hole itself is completely invisible. And here's the mind-twisting part. Black holes don't just affect light, they affect time. The closer you get to a black hole, the slower time moves for you compared to someone far away. This isn't science fiction. It's been proven through relativity. If you could watch someone falling into a black hole, you'd see them slow down, moving slower and slower until they appear frozen right at the event horizon. But from their perspective, they'd fall straight through, never realizing how time outside has nearly stopped. For them, a few seconds might pass. For us, it could be millions of years. So when we say light can't escape a black hole, it's not because the black hole is chasing it, it's because the structure of space-time itself has been twisted so violently that the direction out ceases to exist. It's like trying to climb a hill where the ground constantly curves back beneath your feet. There is no direction that leads out. The gravitational pull at that level is beyond comprehension. To escape Earth's gravity, you need to travel at about 11 kilometers per second, the speed of a rocket leaving the atmosphere. To escape the sun's gravity, you'd need around 600 kilometers per second. But to escape a black hole, you'd need to go faster than the speed of light, and physics says that's impossible.
Nothing in the universe can reach or exceed that speed. Once the escape velocity surpasses light speed, not even light itself can break free. That's why the black hole is black. Here's something even more mind-blowing. Space near a black hole doesn't behave like normal space. It's stretched and curved so violently that it creates what physicists call a gravitational well. Imagine a whirlpool in the ocean. The closer you get to the center, the faster the current drags you down. A black hole's gravity works the same way, but instead of water, it's space itself that's flowing inward. Light is like a boat caught in that current. No matter how fast it moves, it can't go against the flow once it's too close. But not all black holes are the same. Some are just a few kilometers wide, formed from collapsed stars. Others, called supermassive black holes, sit at the centers of galaxies, millions or even billions of times heavier than our sun. The one at the heart of our own galaxy, the Milky Way, is called Sagittarius A star. Despite its terrifying power, we're far enough away that we don't need to worry. Still, it silently shapes the motion of hundreds of billions of stars around it, acting like a cosmic anchor, holding our galaxy together. And yet, black holes aren't eternal. According to physicist Stephen Hawking, they actually evaporate very, very slowly through something called Hawking radiation. Quantum effects near the event horizon cause particles to appear and disappear constantly. Once in a while, one particle escapes while its partner falls in, slowly stealing energy from the black hole. Over unimaginable timescales, this process could cause the black hole to shrink and eventually vanish. Even the monsters of the cosmos can fade away. So let's go back to the question. If light is the fastest thing, why can a black hole still trap it? Because speed alone doesn't guarantee freedom. The black hole doesn't break the rules of physics, it uses them. It bends space-time itself so completely that the direction out ceases to exist. Light keeps moving at full speed, but it's traveling through a warped reality where every road leads inward. It's not that light isn't fast enough, it's that there's nowhere left to go. The idea that something can be so massive that it warps the universe itself is both terrifying and beautiful. It reminds us that even the simplest things, like light, obey the same cosmic rules as everything else. And in that darkness, at the edge of physics and imagination, the black hole stands as a reminder that we still understand only a fraction of how the universe truly works. Now the question is, if even light can't escape the pull of gravity, what hope do the rest of us have against the forces we can't see? Don't forget to like, share, and subscribe for more deep space mysteries, because the more we learn, the stranger the universe becomes.